Step inside the evidence room, investigators. I am your lead detective for today's session, and we are about to completely reframe how you look at your exams. We are going to treat your upcoming Cambridge past papers exactly like intricate, high-stakes crime scenes full of hidden forensic clues. I want you to imagine the gritty, dimly lit space right around us right now. Picture an interactive evidence bulletin board covering the wall. Imagine red yarn linking critical pieces of mathematical text, a case resolution bar tracking our mark potential from 0 to a perfect 100%, and a digital watch relentlessly ticking down your exam time. To crack this specific coordinate geometry case, we have to look closely at the profiles of two very different investigators who I see walk into the exam room all the time. First, we've got Agent Alex. Now, Alex is a strictly procedural detective. Alex gathers vast, towering mountains of physical evidence. We're talking raw facts, memorized formulas, pages of calculations. But Alex totally fails to build a coherent case motive, meaning there is a complete lack of high-level analysis. The examiner looks at Alex's paper and sees a data dump, not a logical argument. Then, on the other end of the spectrum, we have Agent Sam. Sam is our fast-acting detective. Sam jumps to immediate conclusions, rushing to the finish line, completely skipping vital forensic confirmation steps. Sam completely misses the specific command word constraints the examiners deliberately set. Our mission today is to make sure you absolutely do not make the mistakes of Alex or Sam. Instead, you are going to operate as an elite exam criminologist. Let's open the file.
Listen to the senior examiner's explicit warning on this slide. They are telling you that you cannot skip this topic because it is guaranteed to appear on your paper. I want you to think of this quote as a direct, non-negotiable mandate from the chief of police. This isn't some cold case that might arbitrarily pop up once a decade. No, this is an active, serial occurrence. Coordinate geometry, and specifically circle equations, is woven deep into the very fabric of the Cambridge syllabus. If you walk into that examination room without a bulletproof, battle-tested strategy for this specific topic, you're essentially walking onto a contaminated crime scene without your forensic kit. You're going to get caught out. The examiner is telling us straight up that this is the foundation. Every single examination series features these exact principles. And honestly, knowing this gives us an incredible tactical advantage. We know exactly where the suspect is going to strike. We know the territory. We just need to perfectly engineer our defensive response so we can secure every single available mark when the time comes.
Here is our clear, structured case roadmap for today. We'll start with the core principles of circle equations, move into the 5-step procedural framework, talk about mastering the method mark, break down top examiner insights and pitfalls, and finally, lock in your final exam strategy.
Let's start the clock and move into Section 1, Core Principles of Circle Equations, Building the Theoretical Architecture.
This brings us right into Act 1 of our investigation, re-examining the forensic evidence. The theoretical architecture of coordinate geometry isn't just some random collection of numbers floating on a page. No, it is a highly structured, logical grid where every single coordinate is a suspect's location, and every radius is a hard perimeter boundary. To truly master this, we have to look way past the surface level and understand the precise assessment objectives, or AOs, demanded by the official Cambridge Examiner reports. Right here is the crucial formula you absolutely must internalize. X minus a squared plus y minus b squared equals r squared. I need you to treat this equation as the primary DNA sequence of our entire case file. The variables a and b represent the center of the circle. That is the exact epicenter of our crime scene. The r is the radius, effectively the blast radius of our investigation. When you look at this formula, I really want you to see more than just basic algebra. I want you to see a highly precise spatial map. Because think about it, if you carelessly identify the signs of A and B, maybe you drop a negative, you are suddenly placing the suspect in the completely wrong quadrant of the city. Your entire investigation is compromised from line 1. This is exactly where precise forensic work begins.
The truth is, top-performing students don't just blindly memorize that formula. They build connected conceptual understanding, and they actively reference cross-topic connections to achieve significantly higher marks. This is where we separate the basic, shallow descriptive statements from the high-value, top-tier evaluative arguments. Let's look at Agent Alex for a second. Agent Alex might write down a precise definition merely describing what a radius physically is. That's fine, but the examiner wants a causal relationship. They want the motive. How does a tangent line interacting with the circle completely alter the algebraic landscape? You have to explain the why, not just the what. Furthermore, you must aggressively integrate this with other syllabus areas like differentiation or quadratics. When a Cambridge exam specifically asks you to evaluate or to show that, misinterpreting those command words acts exactly like a fingerprint match error in the lab. It instantly, and I mean instantly, throws your entire case out of court. A shallow response gets you absolutely nothing. We need rigorous analytical depth to secure those marks.
Which leads us perfectly into Section 2, the 5-step procedural framework, systematic problem solving.
Welcome to Act 2, the peer interrogation debate. Right now, I want you to visualize agents Alex and Sam sitting across from each other at the metal evidence table. Between them is a massive high-tariff Cambridge past paper question. Alex is frantically trying to overload the response block with huge chunks of generic textbook definitions, hoping something sticks. Sam is practically jumping out of the chair, fighting to build a hyper-fast logic string to just get to the final answer before the case clock runs out. And here's the hard truth. Both of them are going to fail unless they systematically process the data by following this exact standardized 5-step sequence. Step 1. Identify key elements. You have to isolate the raw data coordinates from the noise of the word problem. Step 2. Apply relevant principles. Reach into your investigative toolkit and pull out the exact correct formula. Step 3. Execute analysis with clear working. You must forcefully yet cleanly manipulate the algebra to reveal the truth. Don't hide your steps. Step 4. Verify results. This is where you cross-examine your own answer to ensure it actually fits the physical geometry of the space. Does a negative radius make sense? No. And finally, Step 5. Present in appropriate format. If the judge asks for exact surd form and you casually provide a rounded decimal, your evidence is immediately dismissed. You see, Alex focuses way too much on Step 2 and Sam entirely skips Step 4. You have to execute all 5 of these steps in perfect, uninterrupted harmony.
Let's keep the momentum going into Section 3, Mastering the Method Mark, Earning Points for Process.
In the unforgiving forensic world of Cambridge grading, the method mark is your absolute chain of custody. Think about this carefully. Even if the final suspect completely evades capture, meaning, say, you make a tiny, frustrating arithmetic error right at the very end of a page-long calculation, you can actually still secure the vast majority of the points. But that only happens if your investigative process is flawlessly documented. The academic benchmark prioritizes your analytical depth over superficial breadth, which means you absolutely must show your step-by-step reasoning. Imagine Alex and Sam debating this right now. Alex says, well, I'll just write down every single formula I know on the page. That is superficial breadth. It's a panicked shotgun approach that just clutters the crime scene and annoys the examiner. Sam argues, I'll just use my calculator in my head and quickly write down the final coordinate. That lacks analytical depth entirely. There's no proof of how you got there. The method marks are the vital breadcrumbs of your logical reasoning. Without them clearly visible on the page, the examiner must assume you just guessed, and your evidence is legally ruled inadmissible. 0 marks.
So you must always employ this deconstruct, solve, evaluate mantra. This is essentially the Peel matrix for mathematics. You critically analyze your work and justify your decisions with solid, unshakable evidence. Now, case file freeze. Let's pause the tape for just a second. Before we reveal the ultimate way to lock in this top-band structural framework to help you effortlessly clear your upcoming Cambridge sessions, we need to make sure your intelligence feed is fully secure. Take just a second right now to subscribe to Ace the Exams at the handle @AceTheExams. Turn on all notifications so you never miss our weekly forensic exam updates, whether you are cracking cases at IGCSE, O-levels, or AS and A-levels. All right, tape is rolling. Back to the active scene. When our agents hit an unexpected roadblock mid-equation, right where their evidence links start to collapse under cross-examination, they must rely on this exact 3-step structure to anchor their data. Deconstruct the text. Solve systematically. Evaluate for reasonableness. It flawlessly rebuilds the algebraic logic line by line, creating a completely bulletproof block of text that an examiner cannot ignore.
Moving swiftly into Section 4, Top Examiner Insights and Pitfalls, Avoiding the Traps.
Welcome to Act 4, the interactive viewer evidence room. I am now officially handing the investigation files directly over to you, the audience, for a live forensic check. We are going to dig deep into the archives of the principal examiner reports, which serve as the ultimate post-mortem documents of past exam casualties. This is a vital question you need to ask yourself right now. What exactly separates a perfect score from a frustratingly average one on a topic that literally everyone knows is coming? Let's initiate Challenge 1, the visual clue scan.
I want you to imagine a complex coordinate plane right in front of you. There is a circle intersecting a line with a tangent drawn right at the boundary. A 60-second countdown timer is running on the screen. Why do top students lose marks here? Because they stare blindly at the visual data and completely fail to extract the hidden geometric properties. They look right past the clues. For example, they forget that a tangent is always perfectly perpendicular to the radius at the exact point of contact. That invisible 90-degree angle is the foundational visual clue that cracks the entire algebraic equation wide open. If you miss the visual clue, the math is impossible.
When we read the examiner reports, they reveal these top 3 recurring pitfalls. Let's move to challenge 2. Identify the counterfeit answer. Look really closely at these 3 mistakes. The first is confusing cause and effect. A student might write down that because 2 lines look perpendicular, they must be tangents. No, you have to prove the gradient product is -1 first. Reversing that is false logic, and it instantly destroys your mark integrity. The second major trap is forgetting format. This is tragic. Imagine leaving your final answer as a messy, unsimplified fraction when the judge explicitly demanded an exact decimal form. You did all the hard work and tripped right at the finish line. The third mistake is providing an answer that lacks specific context. Let's say the question asks for coordinates of physical markers on a topographical map, but you give a purely theoretical, unbounded algebraic set with negative distances. That means you didn't even read the case file briefing. You're living in abstract math land, not the reality of the question. Isolate these discrepancies in your mind. We are revealing the examiner's logic live right here.
Furthermore, examiners constantly flag terminology errors. It is an absolute epidemic. So you have to take control of the narrative and actively define your terms before diving into any extended response. When you write down the word tangent or chord or discriminant, you have to realize these aren't just casual everyday words. They are legally binding mathematical definitions. I need you to treat every single mathematical term as a highly specific forensic tool. Let's put it this way. You wouldn't use a fingerprint brush to collect a liquid blood sample, right? It's the wrong tool for the job. So absolutely do not use a linear midpoint formula when the examiner is implicitly demanding a quadratic discriminant to prove that a line does not intersect a circle. Precision in your terminology equals precision in your grading. It is that simple.
Let's lock this down. Section 5, Final Exam Strategy, Securing Maximum Marks. We have arrived at Act 5, Case Closed. Our agents Alex and Sam have finally learned to combine their strengths. They've compiled a final, incredibly high-scoring text block that confirms a 100% case resolution score. But to ensure you can independently replicate this exact success under the massive pressure of the exam hall, we need a system. A highly recommended study hack from top criminologists is to create your own personalized mnemonic using the first letters of those key framework terms. This ensures you never, ever freeze up during the exam. Think of this mnemonic as your own personal code cipher. Create an acronym for Identify, Apply, Execute, Verify, and Present. IAEVP. Maybe something like, Inspectors always evaluate verified proofs. The second that adrenaline spikes and the exam starts, you write that cipher at the very top of your paper. It instantly grounds you, violently transitioning your brain from blind panic mode right into methodical, icy cool lead detective mode.
You must remember that presenting your mathematical information follows incredibly strict conventions, and clear, deliberate annotation is absolutely required to prove your connected understanding to the examiner. Before we officially close this file, I want to distill everything from today's session into 3 unshakable universal rules for your final evidence audit. Rule 1. The 3-step question scan or decoding. First, read the command words, identify your parameters, and explicitly note the required final format. Rule 2. The clock budget allocation or timing. Never, ever spend 15 minutes aggressively interrogating a tiny 3-mark suspect. You are wasting vital case time. Rule 3. The final evidence audit or review checklist. Verify every piece of your terminology and ensure your working is so clearly annotated that the examiner can effortlessly follow your chain of logic from the very first clue to the final conviction.
So, the ultimate question is this. Are you actually ready to apply this rigorous deconstruct, solve, evaluate framework to your next set of past papers? Your very next step after this is to pull up a fresh paper and ask yourself honestly, are you truly evaluating your working to secure every single one of those crucial method marks?
The evidence board is now cleared, the red yarn is packed away, and the active case file is officially in your hands. But before you head out into the field to face your exams, I need you to take action. Hit that subscribe button for Ace the Exams at the handle @AceTheExams. Click the notification bell to lock in your weekly grade masterclasses, and I want you to drop a comment down below right now sharing exactly which Cambridge subject and level, whether it's IGCSE, O, AS, or A level, you are preparing to conquer next. But remember this one fundamental truth, detectives. An equation is never just a random string of numbers. It is the exact, undeniable location of the truth hiding right there in plain sight. The real question is, do you have the forensic discipline to find it? The case file is in your hands. Good luck out there.